Hi, I'm Jonathan Oxer, and this is SuperHouse. The ESP8266 and ESP32 are incredibly popular microcontrollers for IoT projects and home automation. That's because they're cheap, they're easily available, they've got a good range of I/O, and most importantly, they have Wi-Fi built in. If you've ever designed a board that uses one of the ESP series chips, one of the very first questions you're going to have is, what sort of connection do you use for a programming header? If your project needs USB, the answer is right there. Just put a USB connection on it, use something like a CP2102N USB to serial adapter, and put on the little auto reset circuit so that you can take care of it. Then you can plug in a USB cable, load new firmware onto your device, and you're sorted. But for many projects you don't need USB. It's just extra parts, it's more space on the board, extra cost. Many devices can use just a very simple programming header. I mean, a classic example is, something like the Sonoff. You know, the Sonoff Basic has got that little 4-pin header inside it, which gives you ground, 3.3 volts, TX and RX. So what you can do is power it up, put it into bootloader mode, and load your program onto it. That's been done to death. We all know about that. But the ESP series chips need to be put into bootloader mode. That means that there are a number of bootstrapping pins that need to be put into a certain state to get the correct mode. The most obvious one is GPIO 0. It needs to start up with GPIO 0 held to a low voltage to go into bootloader mode. There are other bootstrapping pins as well that do things like set the memory voltage and other things you don't really care about. Most of the time you can ignore those. So what you need is power, TX, RX, reset and GPIO 0. If you can control those things, then you can put new firmware onto an ESP series chip. So you would think that there is a convention or a standard about a header that you can put onto a board and then plug into it to upload new firmware. But there isn't. Now when I've raised this question in the past, many people have said just put an FTDI header on it. FTDI USB to serial adapters are really commonly available. They're used on Arduino related projects. But the problem is they just don't have the pins necessary to do the management of GPIO 0 and the reset line. So unfortunately, an FTDI header is not going to solve this problem. Espressif, the manufacturers of the ESP series chips, make their own programmer, but it's not very well known. So what happens is that people invent their own header formats. I have seen so many. And what I want to do is try to unify these sorts of headers. And we've got the classic XKCD problem. We've got a bunch of standards, we want to unify them, so now we've got one more standard than we started with. But sometimes you just got to do that. So I started by doing a quick survey of other projects that have put on their own headers. Everybody has invented their own header, typically 0.1 inch pitch, and they all have advantages and disadvantages. But there is one very specific criteria that I have in trying to determine what sort of header I want to use, and it comes back to the Sonoff. What I would really like is to see IT standardize on a programming header on the Sonoff that allows you to plug in a programmer instead of using separate jumper wires and then trying to put it into bootloader mode. I want a standard header that we can have a programmer that you plug in and you can just reflash it. Wouldn't that be fantastic? Now, I've been lobbying IT on this personally for more than 2 years now, and they've said positive things. It might actually be coming. But this is one of the things that determines my own decision about the order of the pins and how I want my header format to be set up. Because if we're going to have any chance of IT putting a programming header into the Sonoff, it needs to be not too much of a departure from the existing design. And they already have tooling in their factories for things like pogo pins that go onto the programming header that is already in their devices. So what I'm proposing is that we start with the 4-pin header that is in an existing Sonoff Basic and then just extend it. The header already includes ground, 3.3 volts TX and RX. We're missing reset and GPIO 0. So if we simply extend the existing 4-pin Sonoff header out to a 6-pin header, that will give us exactly what we need. Before I get more into this, I need to step back a little bit and explain what it is that I'm expecting to get out of defining a standard header. A lot of the inspiration for this came from the ESP32, which is an ESP32 based board with Ethernet and Power over Ethernet developed by Patrick van Oosterwijk. So what he wanted to do was have a USB header on it, but save the space on the board and also the cost of putting on the USB to serial converter, because a lot of people won't be using it once the board is deployed. The idea is to put that onto a separate module that you can either solder directly in, leave it permanently attached to your board, and then it's got a USB interface, or you can just socket it and use it as a temporary connection, load your firmware onto it, unplug it, and then your board is deployed without needing all of those extra parts. So where I envisage this going is something similar to what Patrick has done with the ESP32. I want there to be a standard header like on the ESP32, and then we can design our own little programming modules or just have standard ones that we all use and put them in when we want to do the programming, take them out when you don't. Now, because Patrick has gone to the trouble of designing the programming adapter for his ESP32, the obvious question is, why don't I just use the same header as Patrick? That way I don't need to design a little dongle. The header is already there. We can just start using that and away we go. Now there are two reasons. The first reason really comes back to what I was talking about earlier with the Sonoff. I want the 4 pins that are the same as the Sonoff to be the same order as on existing Sonoffs. I think that's the only way we have a chance of getting IT to add a more fully featured programming header to future versions. The other is that it uses 5 volts instead of 3.3 volts. Now this is a bit of a controversial one. The I/O on an ESP32 or an ESP8266 is 3.3 volts. Many boards use 5 volts as their input voltage and regulate it down on board to 3.3 and then run everything locally at 3.3 volts. Sometimes you need 5 volts on your board for other peripherals. So Patrick made the decision to bring 5 volts from the USB connection through to the board on the programming header. And that means there is a mix of voltages on the header. There is ground and 5 volts being brought in, and then 3.3 volts on the I/O lines. Now I understand why Patrick did that. He actually needs 5 volts on the board in order to run some of the circuitry. But I think that's dangerous as a general principle for a programming header. The voltage that you supply to the target board should be the voltage that the board is running at. And that's why I think that what we should be doing is putting in 3.3 volts instead of 5 volts. That way the entire header, all of the pins that go into the target board, are 3.3 volt logic or 3.3 volt supply. So this is the logical conclusion of everything I've said so far. We start with the 4 pins that are on the Sonoff Basic, and we just extend it by adding the enable and IO0 pins that we need to do auto reset. This gives us a header that allows us to load new firmware onto an ESP8266 or ESP32 board without requiring any additional circuitry on the board. All of the reset logic can be taken care of on the little programming module. But let's not forget about the official Espressif programming adapter, the ESPprog. The ESPprog includes JTAG headers. They're a 10-way, so 2x5 IDC header in both 0.1 inch and 0.05 inch pitch. It also has a programming header with exactly the pins we need, once again as a box header for IDC cables. It's a 6-way IDC header, so 2x3, and it's in both 0.1 inch pitch and 0.05 inch pitch. The one thing I don't like about the ESPprog is that it includes a little jumper so that you can select whether it's going to supply 5 volts or 3.3 volts to the target board. As I said earlier, I don't like that approach. I would rather tighten the definition of this header standard and only allow 3.3 volts. That way it protects you from problems like having the jumper in the wrong position and plugging into a target board, giving it 5 volts when it's expecting 3.3, and potentially damaging the board that you're connecting to. So wrapping up everything that we've gone through so far and pulling it all into one place, we now have 2 different header formats, a 1x6 or a 2x3. They can also be in either 0.1 inch pitch or 0.05 inch pitch. That gives 4 options, which is not ideal obviously. The ideal would be to have just one header format. But this does have some advantages and it gives some flexibility on the target. There is one very unfortunate side effect of having 2 versions of the header derived from 2 different sources, and that is the pin numbers don't match. That means that we can't have a single list of pins to signals in the ESPFlash header. This really annoys me, but I can't really see a way around it unless we either drop the official ESPprog header entirely, redefine it, or redefine the 1x6 header in a way that's not going to be even close to compatible with the Sonoff. So this is a trade-off that I think I just have to make. It's also very easy to account for with something like a little octopus adapter. I've already implemented reference hardware for all of this, including both an adapter that's got a USB-C connection on it and a CP2102N USB to serial converter with the reset circuitry and a 1x6 header on it, but also a little octopus adapter that plugs into that and gives you the other 3 possible header formats. With just these 2 simple little boards, it covers all of the options. And of course, if you want to make an adapter to some other type of header, you can do that too. It's very simple. If you start with the 1x6 header, for example, using the ESPFlash standard, what you can then do is make an adapter board that takes that and converts it into a different format if you want to plug it into a board that has some other format of programming header. For example, I found that this flying lead header that I've made is particularly handy. What I did was just solder some color jumper wires onto a 1x6 header that matches the ESPFlash standard, and then I crimped ferrules onto the end to give it a nice hard steel finish. I popped off the plastic covers on the back of the ferrules, replaced it with heat shrink, and then tinned it. What this gives me is cables that I can easily solder onto a target board. For example, if you're doing 2-year modules, you'll often find that you have to connect to random places, and this sort of little adapter is fantastic for that. Now, if I've convinced you that the ESPFlash standard is a good idea, there are 2 things that you need to build it into your projects. The first is you need to put a footprint on your target board for the programming header, in either the 1x6 or 2x3 format. To make that easy, I've already created an Eagle library that contains that in both 0.1 inch pitch and 0.05 inch pitch. In my version of the library, there are multiple footprints for each of the dimensions because it includes 3D models for all of the connector options. Unfortunately, with the current version of Eagle, there is no good way to share a library and have the 3D models embedded within it. The basic version of the library without the 3D models is up on GitHub. Now, if I work out a way to be able to share it with the 3D models, I will do that and update the page accordingly. I'm also going to follow up by adding a KiCad library to make it really easy to put this footprint onto your projects. The second thing you'll need is a programming adapter that implements the header. I've done my own reference version of it. It's all open source. The design is on GitHub, so feel free to copy it, do whatever you like with it. You'll see the schematic is broken down into 5 major areas. First is the USB connection. I've used a USB-C socket. You can use whatever you like, of course. And that feeds into a CP2102N USB to serial converter. You can use whatever serial converter you like. I just happen to like this chip. The other side of the serial converter goes to the ESPFlash header. There is also a small circuit that implements the necessary logic to hold GPIO 0 low while the board is being reset. And finally, there is a 3.3 volt voltage regulator. I've spec'd mine with a voltage regulator that will do up to 600 milliamps, which is great for things like ESP32 boards that pull a lot of power on startup. So if you want to implement your own ESPFlash compatible programmer, just take it and use it. The design is all there. Oh, and just to clarify, I'm calling this header ESPFlash, and my implementation of the programmer I'm calling ESPFlasher. But the idea is that you can make a programmer, call it whatever you like, but ESPFlash is how we refer to the name of the header. Now, just as an observation, when I started this, I thought that I would be using the 0.1 inch 1x6 header on everything. And what I've ended up finding is really useful is the 0.05 inch pitch IDC header. I've implemented that on about a dozen boards now, and I find it really handy to use that as a programming connector because you don't have to have the programmer and its USB cable directly connected to your target. You can have it sitting on the bench with a nice flexible IDC lead plugged in, and it's really convenient. And the header is also very small, and you can't plug it in the wrong way around. So for me personally, the 2x3 0.05 inch pitch header is the winner out of all of this. It's not what I expected at all. Now, as a final summary, this is what we are left with. 2 different header formats, either a 1x6 or a 2x3 format. It can be either pin headers or IDC. And you can do it in either 0.1 inch or 0.05 inch pitch. Now, I think it's obvious from everything I've shown you that there are many engineering compromises in what I've come up with for the ESPFlash header. Unfortunately, there are lots of trade-offs. There are pin numbers that don't match, there are multiple header sizes, but what I've tried to do is come up with something that is a usable standard that we can put into our projects and then not have this big mess of different headers that are happening right now. So if we can standardize on a header like this, That I think would be really good for all of us. And ultimately, of course, if we can convince companies like ITEED to incorporate one of these headers into their Sonoff products, and perhaps if we can get it into the Shelly or any other device that is based on the ESP series chips, that will be really handy for being able to reflash them very easily. Grab your favorite programmer, plug it into the ESPFlash standard header, hit Tasmatize or use whatever software tool you like, and you're done. So, if you are designing a board with an ESP series chip on it, please consider using the ESPFlash header as your programming header. Now, go and build something awesome.